there, 7th graders. It's Mrs. Trombley. It's time for Chapter 3, all about ratios, rates, proportional relationships, etc., etc. So today's focus is just on ratios and rates, which are probably two topics you've heard about before, but as usual in math, we take something that you already know and build on it. So a little review of what a ratio is. It's a comparison of two quantities using division. So basically you're comparing one number to another number. And we say using division because ratios can be written as fractions, and fractions are like little division problems. There are three different ways you'll see ratios written. One of them, yes, fraction form. I'll zoom in a little bit so you can see. And another version, this means the same thing. It's 3 and then there's colon 4. So that just would be said 3 to 4. And you can actually use the word to instead, TO. So those are the three different ways that you'll see ratios. Ratios should always be written in simplest form. So for example, instead of saying a ratio of 6 to 8, you would simplify that to 3 to 4. So let's try simplifying a few different ratios. All right, let's say that you walk into a room and there are 45 males and 60 females. So we would say the ratio of males to females is 45 to 60. If your objective is to write that as a fraction in simplest form, the first thing you need to do is change this into a fraction. So whatever's first is your numerator, whatever's second is your denominator. And it does matter because in division order matters, right? All right, to write this in simplest form, I have to look at what is the largest number that divides evenly into 45 and 60. I know that 5 goes into both, but 15 is actually the largest. So to simplify this, we're going to divide both the top and bottom by 15. 45 divided by 15 would give you 3. 60 divided by 15 would give you 4. So 1 down, right? That's simplest form of males to females. All right, next, let's say you walk into a pet store and the ratio of dogs to cats, it's 12 dogs to 15 cats. In simplest form, first thing we're going to do is write that as a fraction. So I'm going to take the first number as my numerator, second number as my denominator, and I'm going to look and see, okay, what divides evenly into both of those? And let's see here. 3, is 3 jumping out at you? I hope they are both divisible by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. And there we see we have a ratio of 4 to 5, or 4/5. All right, one more of those. Okay, you took a test. You got 15 right and 5 wrong. So the ratio of correct to incorrect would be 15 to 5. The 15 is first, so that's my numerator. 5 is second, that's my denominator. Now when you look at this one's a little bit different because you see, okay, well 15 is divisible by 5 and it comes out to be a whole number. I'm actually going to have you write it as a ratio because that's our goal. We want to write it as a ratio in simplest form. So I know that 5 does go into both of these. 15 divided by 5 is 3. 5 divided by 5 is 1. And you're actually going to leave it like that. And again, the reason you're going to leave it like that is because I want the ratio of correct to incorrect, right? So if you didn't put that bottom number there, all we would have is 3 correct and we wouldn't have anything to compare it to. So when you're simplifying ratios, writing them as fractions in simplest form, you're allowed to leave it as improper. You actually should, because with ratios you need to make sure there's a comparison of two numbers. All right, so that's part 1, all about ratios. Now we're going to talk about rates. And a rate is a kind of ratio. It's a ratio of two quantities, but with different units of measurement. So some different rates in real life that you might know, miles per hour, or maybe with typing, the number of words you can type per minute, or the number of text messages you can send per month. So a rate is something per something else. I'm sure you can think of plenty. Bring them to class with you and we'll talk all about it. All right, so a rate is a ratio of two quantities with different units, just like, and we'll use the example of, let's see, they can type 60 words per 2 minutes. So we have words, we have minutes. That's what I'm talking about with different units. Okay, so a unit rate is a special kind of rate. It's a rate that has a denominator of 1, so that means it's out of 1. Generally, you wouldn't hear somebody tell you, I type 60 words per 2 minutes, they would tell you how many words per 1 minute, right? So usually in life, you would like to know the unit rate instead. I don't want to know how much 5 of something is. I want to know just how much 1 of something is. So whenever you're trying to find the unit rate, you end up using division to figure out what it is, and we'll get through that in just a second. I'm going to give you a big example here. But for unit rate with denominator of 1, I would write out 30 words per minute. So with this, when I say 30 words per minute, we're talking about 1 minute, right? So that's what unit rates are. They're per 1 of something. And they make a lot more sense usually when you're communicating. When you talk about how fast you're driving, I wouldn't say, yes, I was going 80 miles per 2 hours. I would say I was driving 40 miles per hour. Anyway, this next section tells you how to figure those out if you're given something that's not a unit rate. So finding unit rates using verbal description or from verbal descriptions. Rates are written as y per x, or dependent variable per independent variable. So I know that in science you have been talking a lot about independent and dependent variables. In math, we actually end up talking quite a bit about it as well, especially as we get into algebra next year. So knowing which one's which is going to be really helpful to you. But basically when you're given a rate, it's always going to be the dependent variable per independent, or the y over the x. And remember, these are ratios and they're like division problems, so it does matter. You can't do the x over the y. It has to be the y over the x. So, a couple examples here. I ask you to find the unit rate. It says that 30 blocks in 20 minutes. So that means, let's say I went for a jog and I was able to jog 30 blocks in 20 minutes. I want to know how many blocks per 1 minute that is. So when I say 30 blocks in 20 minutes, the number of blocks is actually my y, and the number of minutes is actually my x. And maybe you remember that when you have a unit of time, that's your x-axis, increments of time, the thing you have control over. We'll go into more detail in class. But basically I want blocks per minute, right? So as a ratio, if I wanted to show blocks per minute, that means the blocks would be first on top, and the minutes would be on the bottom. So this would show 30 blocks, and this line also means per 20 minutes. So if I want to know how much for 1 minute, all I need to do is take 30 divided by 20. So when you take 30 divided by 20, and if you have your calculator handy, or maybe you just like to do this, maybe you see the 3 and the 2 and cancel out the zeros and you already know, but basically when I do this division, I get 1.5. Now when you give me unit rates, you need to give me the what per what statement. So this is 1.5, and it's always y per x. So we're going to say blocks, and instead of the word per, I'm going to use this slash minute. I could write the word per if I wanted. It means the same exact thing. So when you're giving me a unit rate, you don't have to give me a ratio. It's not like where I asked you to simplify each ratio and write it as a fraction in simplest form. You're giving me a rate. So you're going to give me a single number and then give me the per statement so I know how much for 1. All right, let's say you are at the grocery store and you see some grapes and there's a sign that says $4.50 for 3 pounds, and you want to know, okay, well, how much for 1 pound, right? I want the cost per pound. So it's dollars are my y, pounds are my x. So all I need to do is take my y and divide it by my x. And when you take $4.50 and you divide it by 3, do you know this one? Yep, you get $1.50. And I'm not just going to write 1.5 because we're talking about money, aren't we? We've talked about this in class a little bit. If you're giving money, you need to go to the hundredths place so that you're giving me cents. Does that make sense? Ba-dum-bumch. Okay, so it's $1.50, and $1.50 what? It's $1.50 per pound. So when I give my answer, I'm going to put a dollar sign in front of this. So this says $1.50, and now there's not a word that's going to go in front of this. It's just per pound. So this shows me how much per 1 pound. That's what makes it a unit rate. A rate right here just says, okay, something per something else. The unit rate, it's per 1 of something. So I don't have to say $1.50 per 1 pound. That's implied, right? We know that that's what that means. All right, next one I have 240 miles, in 4 hours. So I'm looking for miles per hour. That means miles are my y, hours are my x. We're supposed to divide the y by the x to figure out the unit rate. So 240 divided by 4 is how we'd figure out the miles per the hours. And when you take 240 divided by 4, 4 goes into 24 6 times, and we've got that 0, we get 60. And now 60 what? 60 y per x, 60 miles per hour. So basically with this, I would think the trick to understanding which way you divide, because if I said 4 hours, it took me 4 hours to travel 240 miles, I still want miles per hour. Whatever you want per something else, that gives you your order. So if I'm looking for miles per hour, that means the miles is on top, the hours is on the bottom, so that you're dividing miles by the hours. When I want dollars per pound, I'm going to take dollars divided by pounds. If I wanted pounds per dollar, I would divide 3 by the 450. So however your per statement's going to read at the end, that's the order that you want to divide with these. All right, turn the page. So that was a verbal statement, right? We learned how to figure out a unit rate from a verbal statement. I also want you to be able to figure out rates from tables and from graphs, because you're going to see lots and lots and lots of tables and graphs in your future math careers. All right, so how do you find a rate from a table? It's the same kind of idea here. They're calculated by taking the change in the dependent variable and dividing it by the change in the independent variable. Or, and this is a little fancy right here, I won't sing the song, but just know that I'm thinking it. This little triangle means change in y, and this little triangle here means change in x. So basically what you're going to do is look at your table, and you're going to see what your y is changing by every time, and see what your x is changing by every time, and you divide them. So when you're looking at your table, again, this is relating right back to science. When you have a data table, do you remember which variable's on the top? Hopefully you're saying x, and on the bottom we have y. It's always set up this way. So what I'm saying is, to figure out the unit rate from this table, how much 1 of something is, all you're going to do is see what y is changing by and divide it by what x is changing by. And that will allow me to figure out the dollars per mile. Okay, so let's say you're doing a walkathon and you're going to get paid for your distance. We wouldn't want to know miles per dollar, we want to know dollars per mile. So that's why it's y divided by x. Okay, so if I'm going from 24 to 48, 48 to 72, 72 to 96, I'm asking you what the change in y is. I'm asking you, in this case, what's y going up by? Or in other words, 24 plus what is 48? Now some of you are like, well, I know, it's 24. 24 plus 24 is 48, and 48 plus 24 is 72, and 72 plus 24 is 96, right? Now, if you looked at that and you didn't see that, it wasn't obvious to you, all you need to do to figure out 24 plus what is 48 is take 48 minus 24. And that will tell you 24 plus what is 48. Or same here, you can take 72 minus 48, and that'll tell you plus 24. 96 minus 72, and that'll tell you what it's going up by. So if it's not obvious to you, like the next one has decimals. Usually decimals aren't quite as obvious as whole numbers. Then all you need to do is subtract the second one and the first one. Take the second y minus the first y. And here we have our x's, and to get from 2 to 4, 4 to 6, 6 to 8, yeah, we're going up by 2 every single time. So I would call that the change in x. So in my table, once I know the change in y and the change in x, all I have to do to find my unit rate is divide the change in y by the change in x. Those are supposed to be triangles, in case you're wondering. Okay, so we said the change in y was 24, the change in x is 2, and when you take 24 divided by 2, we get 12, right? Now it's y per x, right? The y value is the money in dollars, so I'm going to put a dollar sign in front of this 12, and that's per mile, so I'm going to use my little slash and write the word mile. So this shows me I get $12 for every mile, $12 per mile, y per x. All right, take a look at the next table. This time it gives me time in seconds, 3, 6, 9, 12, and then the distance traveled in miles. So in 3 seconds, we've traveled 14.4 miles. I'm guessing we're talking about something that is like an automobile of some sort, right? Maybe an airplane, something, because that's really quite the distance to travel in 3 seconds. I don't know. Not very realistic data, but it is data, and that's all we need to practice this stuff. So if I want to know the unit rate, that means I want to know how many miles per 1 second. So if I'm looking for miles per second, I need to know what is y going up by, because this is the y. So 14.4 plus what is 28.8. I would just take 28.8 minus 14.4. And when you do that, you can go ahead and do that. When you take 28.4 and you subtract 14.4, you get, you're adding 14.4. And if you were to take 28.8 plus another 14.4, you would get that. So we've got this constant rate of change. It's going up by the same amount every time. So my change in y is 14.4. I'm supposed to divide that by my change in x, right? So my change in x is going 3 to 6, 6 to 9, 9 to 12. We're adding 3 every single time. And again, if you weren't sure, take 6 minus 3, and that will tell you 3 plus what is 6. So my change in x would be 3. So to figure out my miles per second, we need to take 14.3 and divide that by 3. And when you do that, 14.4 divided by 3. When you do that, you end up getting 4.8. Now you're not done when you get 4.8. The whole focus of this chapter is being able to identify the rate. So I need to know 4.8 what per what. And it's y per x, right? Y over the x means y per x. Y represents miles, so I'm going to write miles per, and it's time in seconds. So to finish it off, you have to include that per statement whenever you give me that rate. All right, last thing I want you to be able to do today is identify a rate from a graph. And again, we're still looking for unit rates because that's how rates are communicated. It's always 1 out of 1. So same exact thing with these graphs. It's nice because it's all very, very similar. Rates are still calculated by taking the change in y and dividing it by the change in x. And when we're talking graphs, we're talking about the x-axis and the y-axis. So it's all connected. I probably had a table of values and took those table of values to plot these points, right? So when you're looking at a graph, I'm going to try to zoom out a little bit. Nope, it's not going to let me. All right, when you're looking at a graph, I give you some examples here. This is sound through water. And on my x-axis, I have the time in seconds. And on my y-axis, we have the distance in kilometers. So in looking at this, if I want to know the rate, that means I want to know the y per x. Y is kilometers, x is seconds. So I want to know the sound through water. I want to know how many kilometers per second. To figure out how many kilometers per second, all I have to do is take a look at what y changes by and divide that by what x changes by. It's always change in y over change in x. So when you're looking at this, I give you 2 ordered pairs. We have this nice straight line here, and we have 2 ordered pairs. We say that when time is 2 seconds, when x is 2, that the distance is 3 kilometers. So this right here means 2 seconds, 3 kilometers. And up here I see that after 4 seconds, because that's 4 on the x-axis, it travels 6 kilometers. So in these ordered pairs, this is x, this is y, this is x, this is y. To figure out what the rate here is, I need to know what y is changing by. So from this ordered pair to this ordered pair, what is y going up by? From 3 to 6. 3 plus what is 6? Yeah, it's 3, right? If you didn't know that, take 6 minus 3, and then we get that. So down here I'm going to write change in y equals 3. All right, now I need to know my change in x. So this first number in the ordered pair represents x. What is x changing by? What's x going up by? And this is just like the data table. 2 plus what is 4? Well, 2, right? So when we take the change in x, I'm going to write down 2. So the change in y is 3, the change in x is 2. And now I need to give my rate. I don't want a ratio, a comparison of 2 numbers. I want to know my rate. So when you take 3 divided by 2, you end up getting 1.5. And it's 1.5 y per x, right? We said our y was kilometers, so 1.5 kilometers per our x is seconds. So 1.5 kilometers per second. So when you're trying to find the rate from a graph, it's basically the same as a table. Change in y divided by change in x. Let's try one more. We have a walking rate here. All right, so down here we have time in seconds. On the y-axis, we have our distance in feet. And it looks like after 2 seconds, this is x, after 2 seconds, we've traveled 11 feet. And after 4 seconds, we've traveled 22 feet. So in our ordered pairs, it always goes x, y. I need to figure out what the change in y is and divide that by what the change in x is. So in the y values, I'm going from 11 to 22. To get from 11 to 22, or 11 plus what is 22, or 22 minus 11, to figure it out if you're not sure, but y goes up by 11 to get from one point to the next. When you look at your change in x goes from 2 to 4. So the change in x, 2 plus what is 4? 2. So all you need to do to figure out your rate, your unit rate, out of 1, is take 11 divided by 2. When you take 11 divided by 2, you end up getting 5.5. We're not done because I need the rate, I need the per statement, so 5.5 what? It's 5.5 y per x. So y is feet, x is seconds. So 5.5 feet per second. That's your walking rate. Not too shabby. All right, we're done for now. See you in class.